everyone. Welcome to NOSP in Stavanger. This is the first event this year. The next event in Stavanger will probably be November for the yearly dinner. We have a new venue tonight. Never been here before, but for me it looks quite nice. I hope the food also is tasty. Let's start with the important things, like escape routes. You can either go down the stairs that you maybe come up on, or you can go through that door to another door and then the stairs down to the Kirkegaten on that side. Mustering point is probably across the road on the corner. Toilets is out with the elevator, just turning right there. And there's also a balcony for Stig and the other smokers that you can go out on when you are needed to that. So you don't have to go the 4 stairs down. We're happy to have so many attendees. Actually, we have 35 signed up, so still someone missing, because there should be 36 chairs here. There's some new faces and some familiar faces. And this is an arena for the mingling, partly, but also get to know new people, get to meet ex-colleagues, some professional updates from the industry, from the presenters today. Hope you will enjoy that. And if you have something you'd like to present sometime in NOSP, just reach out to any of us in the board and we'll put you on the list to future presentations. This event is kind of takes place because we have this group of sponsors that provide us with some money, and then we can pay for the food here, we can pay for the location. So we're very pleased to have this group. I think it's 35 now, or is it 36? 36, yeah. It's very good. The board members, see if I can manage to swap here. We change slide. So we have Stuart sitting in Bergen. He changed from DOF to Skanska. So he's the chairman of the board. We have Ricardo here. Derek from Sub 7. Myself, he's Utech Survey. Lepis Swan in Equinor, she might come later, so we'll hello to her. And we have a young guy, Alvin Solberg, who recently joined DOF. So he's our link into the universities and support to get new people to the industry. Just to look at this event plan going ahead. May 22nd we'll be in Bergen. We'll be presenting at Høgskolen på Vestlandet, as we did last year. So there we have room for the sponsors to join us, to put on the stand, to have people there talking to the students as they get them attracted to this industry. There'll become more information on that later. And as I said, it might also be we have an evening event the same day. Then in September coming up with the yearly RTS Subs Innovation Day, and always a success, so we look forward to that. Then it was a long time since we were in Oslo, so we have decided this year we try to get something arranged in September for the Oslo. Back to Bergen in October, and then, as I say, the annual dinner in Stavanger in November 27th. You can just put that in the calendar already now, so book that evening. So then, saying that also, we are live stream, so we are putting this out on YouTube, and in the break, which we have after the 2 first presentations, we stop the streaming, and then we start again for the last presentation. So for the evening tonight, we will have, I say, 3 presentations. We have Christian from Field Group, and we have Freddy from RTS, and we have Ingvild from Havkraft. I think we look forward to listen to all of you, and I think we will then start with Christian.
hope we're on. Good evening, everyone. Thank you very much for inviting me to present today. It is a pleasure to be here at the Norwegian Forum. My name is Christian Glavak and I come from Croatia. I'm currently a project manager and senior engineer at Field Geospatial AS here in Stavanger. I have over 10 years of experience with geomatics, surveying, project coordination. I have executed numerous projects involving engineering, building construction, road and highway construction, 3D scanning using LiDAR and photo technology. I also had an opportunity to utilize various sensors like ground penetration radars, underground trackers, magnetometers, hyperspectral thermal sensors, and pretty much anything you can imagine. So far I've been lucky enough to play with most of modern, very expensive toys, and I would like to present some of them to you today. But first let's take a short info about our company. Okay. So what do? Field is a geospatial technology company that captures, processes, and delivers accurate information across the Nordics and beyond. Our presence is based in Europe, but we operate globally. We have offices in 13 locations over the 5 countries, of which are Spain, Norway, Sweden, Finland, and Estonia. We have over 250 employees with over 70 years of experience joined. Our services are end-to-end geospatial services. So we offer aerial surveying, where we capture accurate aerial data across land and sea with our airborne fleet. We have a fleet of a couple of smaller airplanes, a couple of helicopter setups, and of course drones. In land surveying, we plan, build, maintain buildings, roads, other infrastructure, track and monitor accuracy from project start to finish. We have mapping, modeling, and analytics. From corridor mapping to digital twin solutions, we deliver complex geospatial data with accurate 3D maps and models. We plan, build, and maintain assets. In mobile mapping and geophysics, we capture and analyze detailed 360 degrees information about road conditions, about utilities, groundwater, bedrock, and more. Cloud software. We understand what matters with user-friendly geospatial software, featuring orthophotos, oblique images, 360 panoramas, 3D point cloud for mapping and analysis. And we also do land and property consulting, manage and develop land and property in Norway, acquire properties and property rights, secure land boundaries, manage building applications, subdivisions, and more. These are some products from aerial surveying that we can offer. Of course, there is more, but these are just picked out. From orthophoto, topographical LiDAR, oblique imagery, we have bathymetric LiDAR, we conduct power line inspection and corridor mapping. In land surveying, besides typical surveying and mapping, stakeout and surveying, we offer also monitoring movement, we offer 3D scanning, dimensional control, we have precise leveling, as-built documentation, and one of the newest members of our fleet is HP SitePrint, which we'll talk a little bit later. Mobile mapping and geophysics. So here we have a fleet of cars that constantly drive around Norway, together with a fleet of airplanes flying above us and creating a full mobile mapping solution. 360 street view imagery, road condition analysis, we have ground penetration radar following them, and we offer a wide range of products regarding that. I couldn't have all our toys, that how I call them, here to present, but I prepared some of them to show you. And first and the most noticeable one that we can say is good old Leica RTC 360 terrestrial scanner. We use this scanner a lot, maybe in 50% of our scans. It's a high-performance portable device. It measures approximately 2 million points per second and completes a full dome HDR 360 photo in less than 2 minutes. Its effectiveness is up to 150 meters. accuracy of RTC Leica is below 5 millimeters. We always say 5 millimeters, but we always get lower than that. It's approximately 2 to 3, but you won't see me writing that in email. What's interesting is using this sensor is using VIS technology. That's a visual SLAM, which means that it can be moved in the same area that he's scanning without losing the position. It doesn't lose its position regardless of how many movements you made with it. Next in fleet is SLAM-based mobile scanner. So it's a Navis VLX. It's a wearable scanner. You put it on yourself. You walk through the site and collect the data. It's simple as that. It has 2 laser scanners, 2 pucks, one on forward and one on top of it. It collects approximately 1.2 million points per second. And on top of that, it has 4 cameras that act like a ladybug camera, and it creates 360 imagery on either user input or the distance what you passed with it while scanning. What it does at the end, it basically creates Google Street View, just indoor. You have, and on top of that, it's complemented with a very accurate point cloud, with accuracy around 6 millimeter. 6 millimeter. We always say below centimeter. And it's a very useful tool to visualize complete site from the point cloud, from photos, from we can have multiple inputs. You can scan it in the different stages of building, and you can have all the different stages in a single place. Next one, and one of my favorites, is Hover Map. That's also a SLAM-based laser scanner. It's very versatile, smart mobile scanning device. It's high resolution data. High resolution data capture can collect approximately 1 million points per second, and the range up 300 meters. It can be mounted on a backpack. It can be handheld. It can be mounted on a stick. It attaches to a drone, to a plane, to anything you can imagine. It's built to withstand harsh environments with a very robust design, and it's the biggest thing about it. It's capable of autonomous waypoint navigation. What basically means once you connect this LiDAR to a drone, it completely overrides the drone. It ignores the drone, and the scanner starts to be a brain of that drone, completely navigating the drone without pilot input, completely taking over the autonomy and exploring on its own. And that is very useful for GPS denied areas. Let's say caves, let's say houses that have been in a fire that that we don't know about structural damage, so we need to inspect them. This can be attached to a Boston Dynamics spot, sent in. You get a full scan with 360 cameras, with 360 photos, and you have a full overview of site that you are working on. I have a short video regarding the hover map because I find it very interesting, so I hope that you will find it too. It's the autonomy level 2 showed in the video. So currently we are in a mine, underground, GPS denied environment completely, and there is a danger of falling items and danger of personnel not being safe further in the mine. So to inspect the situation, the hover map was autonomous, sent to check everything and to have precise LiDAR scan, precise 3D data of the area that needs to be worked in. Now, as you can see, there is no input of a pilot whatsoever. He just gave him a waypoint of a height. So the hover map can detect even 2 millimeter thick wires, and he will automatically go away from it. He knows its environment. He rotates slowly when descending to understand what's around him, and came back. once it's finished, once he realizes there is no more, then he goes back. So this all was captured in approximately 3 minutes. We have a live, and we saw the live data as it's being captured, if we are, of course, in a proximity. Yeah, I have another video of our map, which I find more connected to your to offshore industry. So this is a hover map scan of a rig that was docked. It was drone and handheld combination of a scan combined in joint point cloud after. We have a, this is in high deep. It's I think it has been done in approximately 1.5 days, the entire rig. We also used it for flare inspection, for pipe fittings, for different scenarios across the industry. Right. Yeah, next in line is our drone fleet. We cannot say that drones haven't changed our way of work in the last 5 to 10 years. They revolutionized the field of surveying and 3D modeling. It's really accurate, cost-effective solutions. They're equipped with high-resolution cameras, LiDAR sensors. Drones can quickly and safely survey large and complex areas, including those that are difficult to access by traditional means, especially when combined with something like hover map from the previous slide. They enable the creation of detailed 3D models and maps through photogrammetry and laser scanning, and offering precise measurements and comprehensive visualization. This technology enchants project planning, monitoring, and decision-making process across various industries, such as construction, agriculture, environmental management, ultimately improving productivity and reducing operational costs. We find drones being used more and more every day, and we trying to solve the more and more complex problems regarding drones, especially regulations and in aviation. But so far we are on top of the game, and we can deliver pretty much what has been asked for us. Now more to industrial, more industrial side of the industry. We have the Marvel Scan. It's cutting-edge handheld 3D laser. The beauty of this and what's really interesting with this is it has accuracy of 0.02 millimeters. So we used this when fitting the block engines, when precise measuring of pipes, of fittings, in a very different industrial environments can be used and applied, and it's a very useful product. Accompanying that is Absolute Tracker AT50. It's the latest that we purchased in the company, and it's a laser tracker that works with a probe. So basically, instead of a prism in your hand, you have a probe that is constantly tracked by this tracker, and with that you just drag that probe along the edges or along the surfaces that you would like to measure, and this tracker records everything. So it's basically total station on steroids. Accuracy is 0.005 millimeters at 10 meters. So it's almost an absolute accuracy if you think it. It's suitable for large-scale measurements task. It's robust design. It's very interesting, a very interesting tool to work with. Our also one of the latest is HB SidePrint. It's an innovative autonomous robotic solution from HB, designed to streamline construction site layouts. What it does, it basically reads all your drawings in 2D and print them out directly on the floor on a site. It's like looking at AutoCAD on the floor. It's really strange. But it features advanced depth camera integration for comprehensive spatial representation and real-time route adjustment. So it means that he won't bump into things, and he knows where he is in space. He can navigate himself. He has a certain level of autonomy. And it navigates around unexpected hindrances. It can print lines, points, arcs, text, symbols on pretty much any surface. Yeah, but the biggest thing that we like to do is solving complex problems and across the industries. One of those was a digital twin of one of Norway's largest industrial estates for Mo Industripark. They were sitting on a lot of data that was distributed over several locations, personnel and software. Much of data was analog. Some of them was PDF format, some of that was even drawings, maps, hand draw, and yeah, that were brought in internally that we found later. So the board decided that they needed to digitalize. Solution was a digital model of the industrial park that we created using several sensors and the technology, and it was delivered in a centralized and easy to access platform map space. Another one was production forecasting for timber inventory. So they wanted to manage timber inventory in 61,000 hectares of forest land and overcoming challenges connected to climate change, including preventing wildfires. We conducted an aerial scan and yeah, with a software solution that delivers precise information on biomass, species, and trees' health. The customer was also able to calculate future tree growth for every tree in Fritzau's inventory. And maybe my latest and the most interesting project that I had, it wasn't actually in the field, it was in a company that I was before, but it was worth mentioning. We had a very specific request from a community, from a commune, with ferry dock. So the ferry dock, they didn't have any written, they didn't have any documents about the ferry dock and how it was built underneath. And it, as you can see, as you will see, it stands on old rail tracks, who are embedded in seabed, and then the poured concrete all over the place. So it was impossible to get underneath the dock and scan it, and it was mission impossible. They told us that they've contacted a couple of companies and nobody could handle it, so we had to try it. We had to do it. We came to agreement. We were planning for a long time. We had to plan for a low tide. We had to plan for a good weather, because it was the weather was increasing the sea level. And what we did, what we came up with is to drill a couple of holes where we put RTC stickers inside for referencing. So I think we had like a 7. We used some of blowholes, and we drilled a couple of them too. And what we did, I basically jumped in the sea. I got the scanner in my hand, the handheld scanner, through one of those holes. I scanned underneath, floating in something like this. Yeah, it was definitely interesting and challenging task, but the results are speaking for themselves. The client was very happy. We managed to get everything what they were asking from us, and we enjoyed every second of it. This is the final result of a pier. This was completely unaccessible. I had to actually dive underneath to go inside, under the water. So it definitely was interesting. That's pretty much reading for me, I believe.
Okay, thank you, Christian.
Thank you very much.
I think we can see if we have any questions from the audience, maybe. Yeah,
Absolutely.
very interesting topic, and
Yeah. We can.
tours that kind of are impressive.
Yes.
to play around with.
It was also like really brief, so if you have more questions or inquiries about any technology, we have a lot more. This is just maybe 1/10 of what we actually have at disposal, as I said. And yeah, you can always contact either directly company or me on email, and it's really not a problem. Thank you.
Okay, questions behind there, yeah?
Yep, sorry.
I
Ingrid?
was just curious, are you planning to develop also subsea, like robots, drones, ROVs with the cameras and the equipment that you have?
I cannot say for the future at the moment. I worked with rovers like that, and I do not think that field will go in that direction.
No.
Yeah. We offer more. Yeah.
Adrian?
I can add that there is actually software available where you can map both the surface and subsurface and put it into the same image. It's available.
Adrian?
The laser scale of the rig, what is the color scale? What are you coloring it as?
Yeah, that was dip 90. It was intensity.
From the returns of the laser?
Yeah. Yeah.
So any more questions?
Thank you very much.
Okay, thank you.
Thank you.
Okay, then you ended in the water here, so I will continue then in the water with next presenter, Freddie Knudsen from RTS, talking about this Goby Wave Charger from concept to operation.
Almost operation.
Almost, right.
Okay, thank you very much for the invitation. I think I've done a similar presentation what I did last year at the NOSP event in Åkran, was it? Yeah. So, and the good thing, we have moved forward from the initial idea. So, just going to give you some background. RTS, some of you know it, the company. It was actually me and a colleague who started the company in 2002, so it's been a while. So from the very first start till now, so you can see we have grown in the amount of employees and revenue and everything. So it's definitely moving forward in these exciting times. Yeah, so for those who doesn't know what we do product development. We have several, yeah, I would say industry standard products like the SDM, which is a very recognized system for deflection monitoring of large structures. We have multiplexer, we have the Nemo, so yeah, all in all a good mix of different technologies. But I'm here to talk about the wave charger. I used to manage RTS. Then I left it to someone else. So then you got bored. So you have to come up with something new. So, and the background why we started looking at wave charges is that I have a father who's, well, he likes to invent stuff. So he had a concept he started many years ago, but that was more to produce power to grid. But what I saw that the idea of producing local power is very it's actually quite a good idea, because some places you have access to power and some don't, you don't. So and since we are in the instrumentation world already, or I had an idea of okay, can we make something that charges instruments and also communicates and produces its own power. And as you know, everybody who's been out in the North Sea, it's a rough environment. We know the forces, we know all the challenges, or at least we think we know. So it has to be designed to withstand the environment. And also be able to scale the technology was also one of the design criteria. So you could say, okay, you need this and this amount of power for this application, but maybe for other applications you need more. So that's also one of the considerations we were having at the initial thing. So we started thinking about the rough concept in 21. We saw that, okay, this is maybe a simple idea, the concept we came up with, but we also explored the possibility of filing a patent application. And we did some investigation. We took contact with a German patent office, very experienced. We haven't got a patent yet, but it turns out that even if this looks like a quotes simple idea, it looks like we're going to get a patent. First European, and we also filed for the PCT, which is kind of an international, or then we have to choose which countries around the world or globe we want to file a patent to. So, but so far looks very good. So this is a more detailed cut-through version of what we are building. So we have different parts here. We have what we call the sea anchor, which is in the extension of the sea anchor. We have a rod. On top you have an antenna and an electronics compartment. And then you have the flotation part, and the generator is fixed to the rod. So that's the main principle. It's not just something we threw together. We actually have done a lot of calculations, because as you will see, what we have here is two moving parts, and when they move in different phase to each other, something happens. So, and also for the sea anchor, we have the battery department, but it also allows us to put in different instrumentation in the sea anchor. In this case, illustrated by an Nortec ADCP, I think it is. So, as mentioned, we need to make it configurable, scalable, and also cost-effective, obviously. And as you see, able to power a large number of surface and subsea sensors. And in addition, you get the zero emission. There's actually very little emission connected to this. So we did some model testing. We didn't start with this version. We had a smaller version, which was probably a quarter in scale of this one. Did a lot of testing, found the different form factors that will kind of play together in this. And but then when we scaled up, it sounds easy, but it also introduces some challenges, because working in a small scale and then you add that by 4, you'll introduce some new challenges. So I mean, we have a lot of knowledgeable people at RTS, but a lot of the knowledge around this concept we can say we don't have. So we've been working very closely with an environment up in Morley, which is the Stad towing tank. So that's kind of the equivalent to Sintef Ocean. So they have a test tank, and they have a lot of instruments. So here you can see there's a carriage, and there's a lot of cameras that can. They don't use MRUs or anything like that to monitor motions. They actually use cameras. So it's kind of a photogrammetry live thing, which is very accurate. So very useful data were gathered in order to build the kind of characteristics for the buoy. So okay, so you're building a autonomous buoy, but why? You know, what can you use it for? We've done a lot of these stunts before. So you build something, make it work, and then you try to find a market. So it's kind of the opposite way around sometimes. But when we saw that we had a concept that would actually work, we started to go to trade shows. We started to call people, did a lot of business intelligence, and found quickly out that there's actually a lot of applications for this if we can get it to work, obviously. So we just did some random calls, like for instance we called the Havforskningsinstituttet, which is kind of the Norwegian Ocean Research Institute. Didn't know anyone, and we said, okay, we have a concept here, we have a charging buoy that you can put on instrumentation. Can you use it for something? And they said, yeah, let's think about it. So after a couple of weeks, they called us back and said, yeah, we have a station in the Hardanger fjord. So we are going to try to improve the work processes, because they have a few ADCPs. I don't know what they do with the data, but anyway, it's like a test station in the fjord. And just to run it, there's a lot of issues with changing out batteries in the sensors, gathering data, and that needs some boat operations. And they said, okay, if we put something like this, or if you get this to work, we can save a lot of boat time. The maintenance budget will be reduced dramatically. So and also we can have the data in real time if we want to. So well, good. That's a goal. At least we have someone that believes in the concept. So so let's start build one. Well, actually, we started to build two then. The challenge with being in a fjord is that, I mean, it's wave power. We quickly found out that the wave height was very limited. So, so how do you extract power from the waves when there's hardly any waves? This is just to show you. This is the first one built. So just to show you the movement there. I can run it again, and if you see the antenna part, which is obviously the top part, sorry. So you can see that's very stable, and the buoy is actually following the waves, and that's the whole concept of this. Just to show you some of the other parts, we have in the antenna mast we have various sensor arrays. We have MOUs. We have any means of communication, and that's kind of where the data is gathered from the different sensors and stuff. And this is the sea anchor, so you can see it has an ADCP fitted in, and the metal box is the battery box. So so the concept is that you generate power, put it into the battery, and have the power ready for a rainy day. So and this is what we had to do in this for this Hardanger fjord, because you have, as I said, very limited access to wave, but sometimes you have good wave conditions, and then you just have to get so much power out of the waves as possible, and charge the batteries and use the battery to power the sensors afterwards. How am I doing in time?
Okay, yeah.
Okay. Yeah. So I can say where we are now. This is the Goby #1 being tested. We always find some challenges. One of them was that inside we have a turbine inside, which is made of different types of plastic. So we were testing in 15-20 degrees of water inside a test tank. Everything was running smoothly, producing power. And so we put it out to sea, which is like 6-7 degrees or something. And something happened. It just stopped. So we found that there were some challenges with the materials we have chosen. So when it came into a colder environment, it actually jammed. So lessons learned, but fixed now. Again, you can see that it runs smoothly. You can see there's a buoy, small buoy here. It's actually just been moored with a single line. So it's the whole construction is free floating. There's nothing. There's no tension or anything. The idea is to keep it as free floating as possible. So here we can see some some results for the power generation. We were a bit unfortunate because after we put it outside the test tank in the sea, it's been very calm. So we are not always hoping for bad weather, but in this case we are doing that. So we hope to see some waves soon. But this is a plot which is made just a few days ago. But you can see that we had a very variable power generation, and that's also introducing a lot of challenges. And so luckily we have a lot of clever people of how to handle these problems. But so we also are putting a lot of effort in how to efficiently extract the power from the generator, because obviously it's varying very much. As mentioned, we have built two. Hopefully we have done all the testing by the end of April, and then we will put it to work for the HI, or Havforskningsinstituttet. Number two, we are working together with Kongsberg Discovery. They want to use it as a instrument platform and test various acoustic stuff. I don't know. They haven't really decided what to test yet, but I think they are introducing some new ADCPs, and they have some other acoustics they wanna test. So that's going to be, the next challenge for us, which is going to be interesting. So when we're starting to see the end of the development period now, so within say half a year, I think we are ready to scale up production on these and start to deliver them to the market. So I think we are en route to that.
Okay, thank you.
Okay.
Thank you, Freddy. Interesting. I think I remember the last year as well. Yeah. Any questions to Ingrid?
I was just wondering, what is this installed capacity of your units, the one you're building now? How much are you producing?
I think we still have some testing to do, but I think this one we have around a kilowatt peak power, but obviously it will depend on the wavelength, the wave frequency. So there's a few things to consider, but that's around that figure, you know, on the quite ideal.
Yeah. And one more
conditions.
question, are you developing this for every wave climate, or are you focusing on some particular areas like inshore?
No, I mean, our goal is to not to have them in the fjords, but to have them in the open sea. So we are, and that's why we have spent a lot of time of testing and try to build up models to see how they will react or act in various wave conditions. Because obviously we've got new challenges with longer waves, with shorter waves, and there's a big puzzle to get everything played together. It's with a turbine, how the turbine wings are rotated, just a lot of stuff.
Thank you.
Is there a depth limitation? Can you go as deep as you want?
Yeah, basically.
No.
Yeah.
And size? If you make them bigger, does it produce more, or does it?
It produced much more. So so size-wise, this is close to 7 meters from bottom to the mast top, 1.2 meter in diameter. But if we increase that to 3 to 5 meters, then we will be up in 15, 20, maybe 30 kilowatts, maybe more. So.
Steve?
Oh, yeah. In the future, if you compare it to wind, anyway, is it competing maybe in the size when it comes to the cost? Or is it more based on the instrument and drones and...
I think we start, you know, it's just, as I mentioned, my father, he had a dream of competing with windmills, but I think that's a far fetch. I think that's going to be very challenging. So I think we start with having something that can produce local power, power instruments, power batteries, subsea, and then the future will just see what it ends with.
Apologies.
Hello, Elizabeth.
Ben?
If you go offshore, how would it be withstanding storms? Like initially, when you design an offshore structure, you normally have 100-year wave design criteria and all that. But do you have sufficient length, or will you have that as when it comes to a wave that it will go up and maybe lock itself and then stay away for the waves, so that you actually don't expose it for the kind of, because I guess the electronics is within the buoy itself. So kind of, can you go into a hibernation mode or something?
No, the intention is that when the waves are high enough, big enough for this one, what will happen is that both parts of the buoy will act as one. So that's the design we are done, and the simulation and also tested. So, but obviously still to be seen. Well, we're going to have number 2 outside our office, and you've probably seen the conditions there. That's brutal.
You
Sometimes.
see it as rough, so.
Yeah. So it's going to be tested in the worst type of environment.
Yeah?
For the communication part, is it connected to Inmarsat or Starlink or something like that, so you can transfer data?
Well, it's what we try to do is to build an autonomous instrument platform. So you can configure yourself what kind of communication means. We are just making the infrastructure ready, So what do you want to put on the subsea side? It's up to you. We're just making the infrastructure. So this is like the tractor, but if you're going to have something added to the tractor, you just add it on.
One last
Okay,
question. Is there a storage capacity as well? Can you store the energy that you create over a longer period of time?
Yeah, for now we have a battery, or batteries, actually two. So we are charging them, as mentioned, but we have been in meetings with other interesting parties which are looking to charge subsea batteries, for instance.
I would imagine people that have, I don't know, wave rocket boards or like things that have batteries that maybe can go without.
Hmm.
Could be interested in it.
Yeah, we are building wave monitoring into this as a standard as well, so you can use it as a wave rider basically. Mm.
Okay, any more questions? Ready? Okay, thank you, buddy. Very good. Then we'll take 10 minutes break. So we're back here, yeah, 1940, you can say. There are a lot of food left on the tables. I hope you can eat more. You can get rid of this before you leave. And the bar is also open outside if you want to fill up your glasses.
I'm first.
Thank you. Okay, let's start with the last session then. So now I really enjoyed to welcome actually Havkraft back to present as well. They were presenting for probably 4 years ago, and that was during COVID, so it was a remote presentation. So this time we have a in-person presentation from Ingvild, talk about how Havkraft can be a game changer for offshore operations.
Wow, I thought that was the last one.
You're the last one, yeah?
Okay, I thought it was more. Oh, that is a surprise. Very good. Okay. Yeah, I just have to find it. Okay. So, how Havkraft can be a game changer for the future oil and gas development is the title of my presentation. And I'm going to start by saying a few words about myself, because I was advised to do so. But I didn't see the others do it, so now I feel a little stupid about my slides. But okay, here you go. This is me. So my name is Ingvild Bakke, and my career started approximately 23 years ago after I graduated from NTNU in informatics and geography. I landed my first job in Stavanger, working for Statoil in the exploration department, working for onshore oil and gas exploration. Doing that for a few years, I was asked to join the offshore wind group to do some screening of the Norwegian coasts where we could put bottom fixed and floating wind, and this was in 2006, so it's the really early days of offshore wind. And we did a screening of that. And it was pretty good, I think, because they asked me to come back and do a global screening of the whole planet. So we did a global screening of the whole planet, and it resulted in 5 focus areas of offshore wind in 2008. And these are still the valid locations today, so I think we did a good job. And I was joining the Doggy Bank wind farm development, doing the GIS and the mapping for that project. Before I thought that offshore wind has become too mature for me, so I started to do something else, which is carbon capture and storage in 2009. And carbon capture and storage is, at this time, extremely immature. And we're trying to find partners that will, capture the CO2, and partners to transport the CO2, and us to develop a storage for CO2. So this is what we know today as the Northern Lights. But this was really, really early days, and we were traveling all across Europe to find these partners, and we had to teach them about CO2, really. So eventually I started to work for the Mongstad, the full-scale plant that we had there, and the project we had there with the government. And after that became too mature, I had to do something else. So I started to work in the innovation lab in Equinor in 2017 with hydrogen. And we were a nice team that proved that hydrogen has a natural part in the value chain of Equinor. And or it was Statoil at that time. And actually it was taken into the strategy after this project, and I moved over to something which was very immature. I moved over to Aker BP, started to work with technology and concept development in Aker BP, and I did a lot of things, but I'm just bringing this picture. It's a robot that we developed for offshore. It's FPSO, it's a complete surface maintenance robot doing all the operations without any harm to the environment. Nothing is falling to the sea. So that was fun, of course, but I had to move over to something completely immature, which is Wave. And this is where I am today. I am working for a company called Havkraft. So we are wave power technology developers. That's what we are. So why wave power? First of all, the geopolitical situation is demanding that we have energy security as priority number 1. It's really, really important for everybody right now. The second point is, of course, that
the energy transition requires us to think about new stuff, not only wind and solar and other green things, but we have to think new. We have to think new stuff. And even though ocean and wave technology is not new, it's not mature. But 70% of the planet is ocean, and ocean contains a lot of energy, and it's therefore a natural part of the energy mix in the future, we think. But of course, to get there, we have to try and we have to fail, try and fail, and try and fail until we succeed. And that's what is our goal. The potential, I'm just going to say a few words about that. I'm sorry, my voice is not very good. But we have ocean technologies. It's a mix of different things. It's tidal, it is salinity gradient, and it's ocean temperature technologies, and there is wave technologies. And if we theoretically put all this together and look at the ocean, which is 70% of the planet, we could theoretically produce almost 30,000 terawatt hours. And do you know what the global consumption of energy was in 2023? That's the number I have. What we consumed all over the planet. 23. So theoretically, of course, we could power the whole world with ocean technologies if we had this technology available. So EU knows this. EU says that wave technology, not ocean, but wave is going to provide EU with 10% of the energy mix in 2030. No, in 2040. So we are aiming for that. Of course, that would be, I think it would be 500 megawatts for wave technology alone, but that's doable. Really, that's doable. And there is a race going on. There is a lot of companies developing this, and we're not competitors. Like our friend who left, but he's not a competitor to us. He's just doing the same thing. There is room for more companies doing wave technologies, really. So there has been more than 1 billion euros provided in R&D for R&D activities in wave. And EU has implemented a strategy that 100 megawatt should be implemented before 2025. It hasn't happened, I can assure you, but there is a lot of effort going on. So 1 gigawatt by 2030 and 40 by 2050. So EU did lead the way. There is a lot of European countries that are really into wave, like Denmark. Scotland has claimed itself to be the leading nation of wave technology. And Germany and France is doing a lot of stuff, but of course the Asians are coming and the Americans are coming, and they are closing the gap a little bit faster than we hoped for. And Norway, as a big coastal nation, we have a long coastline, a lot of traditions within the maritime segment. We should definitely be doing wave technologies. So this is a little bit of the background why we exist. So this is the company. I have with me a super group of people who has become very skilled in wave technology, because they didn't come from wave technology, but they have become very skilled. So this is a super group, and we are growing. Two of these people that you see there, like Prithvinath and Bardur, they have just started the company. So we are a growing group of people, and we are establishing an office in Stavanger, because we have currently an office in Nordfjordeid, which is a little bit remote. It's not a big town, so it's a little bit hard to establish the company growth in Nordfjordeid. So now we are in Stavanger as well. So the company background, I would say we are getting closer. We have existed since 2009. We have had several concepts going on in the lab, especially on PowerPoints and then Excel spreadsheets. But we have tested five models in this Stad towing tank, which our friend showed us earlier. The Stad towing tank, which is like a Sintef marine pool. So 5 of them has been tested there, and we had 2 concepts that we have been into the sea with. So we have got a little bit in circles. Are you familiar with the technology readiness level ladder? It's like from TRL 0 to TRL 9. And we're kind of going up the ladder to 3, and then we're maturing it to 5 and going in a loop, because we have to improve stuff. So now we are going in the lab again on Wednesday, and I'm super excited about that. So the lab is on the schedule now. It's ready to be deployed into the pool to test everything, and in October we are in the sea again. If everything goes as planned, we are in the sea with our new concept. So I would say we're getting closer. The team has developed and proven a really good technology understanding of the principle we called the wave energy converter that we have, which is based on something we called oscillating water column. I will come back to it. But it's really like an air stamp. And if you look at, this is just one of the tests we did on a Ulsteinflåte. It's like a barge, 25 meters long. We tied it to that and tested it. We found out the barge was too wide for us. It didn't help us. But if you look at this stamp over here, this is really what it is all about. It's an air stamp. So this is not taking into account the pipes that you see, the yellow parts on this model. But you see that the waves are moving into the structure and using the water as a force to stamp the air up and down. I will show you in more detail in another slide. So what is our goals? We have really, not hairy goals, I would say, realistic goals, but we are aiming to become one of the most competitive wave power units, or to build one of the most competitive wave power units in the market. And we will qualify and commercialize 2 concepts before 2030. And it's not an easy road and an easy way. This requires a lot of resources, of money, people, competence, and customers also. So wave power units are not able to, you're not able to standardize them completely. You have to make adjustments to the wave climate that you are supposed to put them in. So if you build something for the Norwegian coast, you cannot just easily put it somewhere else in the world. It doesn't work that way. You have to make some adjustments. But we're going to standardize as much as possible. And it's going to be easy to access these units, and it's going to be easy to move them to a new position. So what the value for the customer should be is, of course, to reduce their CO2 emissions. And secondly, they are going to get power to continue operating their assets, really. So this is the principle that our concept is based on. It's not going to look like that, but this is a picture of how our patent is. We have like 30 patents globally. And so the water comes into these pistons and providing vacuum and pressure in the towers, you can see. And this vacuum and pressure is actually creating the turbines, which you can see is the yellow part here. The turbines are moving because of the air. It's like an air stamp, really going up and down. And the turbines are still rotating the same way. You see? So this is actually the concept, but it doesn't mean that we are going to build 4 chambers in every structure that we do. Maybe we are only using 2. Time will show. Our units are pretty big. We are aiming for at least 100 kilowatt, up to 500 kilowatts. That's our goal. And the benefits of our converter technology is that with only one chamber, only one of these chambers where the air or the wave comes in, you can produce this amount of energy. While if you increase it with another one, you can take up more energy from another spectrum of the sea, because our openings are going in the vertical direction, deeper. And we're picking up more energy from the space than what you can do with just increasing the width. So that's what's make our patents really unique. And we try to develop this as efficient we can, of course. When you are doing wave technology development, there is 2 things. First, we call it HVAC, and HVAC is Havkraft Wave Energy Converter. That's the short name for that. But within that, there is a structure. There's a physical thing which you can see. It's like we have to design it and make it really efficient and good, and we have to work with the materials, and we have to work with the mooring or anchoring or the monopile or the other structure it's going to be connected to. That's for sure. And then we have the other part, which is the control system and power takeoff system. And it includes the generator and the turbine and all the sensors and instrumentation and power electronics. And this orange part is going to be the same for every unit we produce. So we're developing it now, but of course later we can change the HVAC geometry and size and everything for each customer, but we could keep the control system as it is. So it's a lot of work for a lot of different disciplines, really. So we have two concepts, as I said. One is what we call fixed to a floater, and that's not. It's something that is fixed to another floating thing, like a rig or a boat. It could be connected to a rig and produce. I'll come back to it. And the other one is free and it's floating independently, and that's much harder to develop. That's why it's a little bit later in the scale of maturing, as you can see here. It's going to be matured in. It's going to be a little bit later than the first one because when you are going to control the elements of the sea, you need to get control of, I think it's 9 dimensions of the sea. It's moving in every direction, and once you get full control of one, the other one is making a problem. So this is a little bit tougher, so that's why we're doing it in two different, two different concepts, and one slower than the other. So we need more time on this one. And then back to the topic of today, what my presentation was all about. How can we actually be a game changer for the oil and gas development? It sounds very hairy, but it's true. Because, as you know, in the Norwegian continental shelf, there is not much oil fields left. There's just small finds, like small, what do you call them? Small oil fields. And it takes them just a few years to develop, not like the ones we have, which takes 20, 30 years to complete. These are so small that you cannot defend building a platform on top. It's too costly, because there are only room for development in a few years. So what the oil companies are struggling with is to find economy in this one. How can they do this? They can put a subsea template, of course, over the wells and put some pipelines into it. But as you all know, I'm sure all of you know that cable costs are extremely high. So if they're going to pipelines, they must have. They cannot send them electronically, so they need pipelines. They need the subsea template, and they need the wells. There is no way back. They cannot come around that. But there is a way around for the cables. So what we are doing is we are preparing a concept for the oil and gas, which can float above these small fields, and we can produce electricity enough and have power supply enough, and also be the control room, which is sending the signals back to the control room onshore. And also they need a little bit of chemicals to work, so we can also provide that in our solutions. And so we are preparing a new concept for the oil and gas, which is enabling them to develop these small satellite fields, or whatever you should call them. So that's one. That's why we are a game changer for oil and gas. We're enabling them to build out these small things. The other one is that in the rig world, I mean, this is an AI-generated picture, and I think maybe that the wave power plant is here, if I'm not wrong. I'm not sure. But anyway, the rigs, I mean, the operators are taking in rigs to do a lot of work. And when the rigs are fueled on diesel, these emissions are ending up as a scope 3 on the operators list, and they don't want that. So, of course, if we can produce green electricity to the rigs to take down a little bit of the diesel usage, we can have a lot of benefit. So not only that we are reducing CO2 emissions, but there is a lot of costs related to the emissions, and there is a lot of costs related to the use of diesel, because they have supply ships coming in with diesel a lot, so it takes a lot of time and cost, just that. And also, with putting up a wave power plant on these legs, you also reduce the noise on the rigs, which is very beneficial for the work environment. So that's why I'm saying that Havkraft can be a game changer for the oil and gas industry. And that was the last part, but please follow us on LinkedIn so you can see all the exciting things that I hope is going to happen. And if nothing happens, then I will not be back next year.
Thank you, Ingrid. It was very interesting. Yeah. And any questions for Ingrid? Yeah.
What is the design basis on the structure that you are designing? Is it a floating storage unit? Is it what is the classification by DNV? Or?
Yeah, we're working on to find out which classification we need to be within. It depends on who the customers is really. So we are.
But you're going to be deployed for more than 5 years deployment, or are you going for short time? Are you being mobile? Are you going to be an asset, permanent? Or
yeah. When it comes to maintenance, we believe that we have to take these devices up maybe every 4th or 5th year to take off all the algae. And but when it comes to we design them for 20 years. Yeah, that's what we hope for. And also, it's really easy to go in there and just change out components. Like you can change the turbine or the electrical circuits, and yeah.
So it's like a dual hull catamaran principle, basically, with a anchoring feature.
Well, I don't know exactly about that. You should come and work for us too. Yes.
So I couldn't read the output. So what is the expected megawatt or kilowatt that you will have produced per hour?
Yeah. Our target is to produce between 100 and 500. Not because we cannot go any further, but because we see a market in that segment. That's what we are going for. So 100 to 200 kilowatt is ideal for us. And then we can scale it up and make a park if it's desirable. Maybe in the future when we can feed the grid.
Do you foresee to have a battery so you can have capacity like you have
Absolutely.
energy storing? And
Yeah.
Okay.
But we want to have them on the units.
Yeah.
So we need batteries. We do that. And but also we could think about the way of a wind farm. When you produce energy in a wind farm, it goes a little bit like this and all down, and it stops. The wind stops, and it's really like this and this. But if you put a wave power plant or a unit, some units within the park, it will create energy all the time. The curves get smoother and nicer because of us, really. So, because there are much more waves than wind. Yeah.
There's a lot of small islands in
Yeah.
Norway
Yeah.
along the coast.
Mm.
Would it be feasible to, for example, have one outside an island and
Absolutely.
feed the public that live there? Or?
There is so many areas we could use this for. I think I have 9 market domains, but our target is the oil and gas right now. But of course, we could do this for any community. But I mean, this is a matter of who can pay for the development, because a small island community cannot pay for a development. But when these are commercially available, there is no problem for them to take this into. Yes.
Yeah, you kind of answered my question, but can it be deployed in cities, city ports, near cities?
Absolutely.
Yeah.
It's like a wind farm, really. It's just not so visible, and it creates no noise,
Yeah.
and it's no danger to the marine ecosystem. It's studies has proven that it has no effect on the environment. So, and our structure, I forgot to say, the most nice thing with our structure is that ocean or waves comes into a fixed unit. It's not any rotating equipment in the unit. Everything which is rotating is up in the air. It's not in contact with any water. So we like this principle because we think we're going to have much lower maintenance cost than most others. Because most others are taking advantage of the movements in the sea, in the structure itself. So something are rotating or something are anchored together or something. We think they will have much more maintenance cost. Yeah. Any more questions? This was a little bit fun.
Yeah, does the direction the waves are coming matter? Does
Yeah,
the
it does.
equipment rotate
Yeah.
to the
And that's
dominant direction?
version number 2. Yeah, but it matters, yeah. So I'm thinking that it would be beneficial if we could make a solution that could take advantage of the moving waves. Yeah.
And is it like reliable enough to replace the diesel, like you mentioned?
No, I don't think we could replace all the diesel. It means that we need to have surplus batteries then, so which could take could produce when there is no waves.
Mhm.
So no, I would never just go solely with just wave.
Mhm.
That's too risky at the moment. But maybe in the future.
Are you looking at other options like tide or currents as well, or is it
No.
just waves?
No, we are very focused on the 2 concepts that we have. We believe in the technology and we believe in these concepts. So yeah, I've had some questions from others who maybe wants to ask us if we also could look into other stuff, but no, it's not our priority right now. I mean, this requires a lot of effort to have an innovative company who is developing without any sales yet. So taking care of your money and use them wisely is one of the goals.
Question of funding then is, okay, I assume with Europe has a plan of 10% within 2040 or 50, they must have some kind of funding to put into this market then.
They do, but it's a battle to get this funded, these fundings, because I was in Brussels last week and they said it was so many applicants that the success rate is going to be super low. So it means that there's a much more wave companies coming on the stream, which is good really. It's good.
But Norway then?
Yeah, Norway doesn't have any schemes for wave, and we're a little bit disappointed about that. We have to compete with the priority, which is offshore wind and hydrogen, and it's not easy to compete with them. But yeah, there is, we could, but there is no dedicated scheme. No.
Okay.
Glenn?
Like he was asking if you're also looking to merge the tide, because initially if you don't want to do the tide migration, you're actually limiting yourself to either a band where you say what is the maximum tide, and then initially the geographical spread where you can deploy these, similar to what you did with the startup project where you can install bottom anchored windmills, because tide is initially already a global thing where you have maybe only 35% of it is less than 5 meter tide. So you're reducing yourself to a very geographic band. So you're just kind of 6 degrees north of equator or 6 degrees south of equator.
Mm.
It's a very limited area.
Yeah, but there are regions in Norway which are not so much affected by the tide, and
It's still the 6 degrees
yeah.
south north of equator.
yeah.
That's why if you include the tide, like you were saying, increase the proportion to maybe another 40% if you can do a conversion of tide and waves. So
I think it's a good idea, but maybe after we complete what we are working on right now, because you add more complexity in and you will never finalize anything. So, but it's a good way of thinking in next steps, like you said also. So there are several versions coming, I hope. And version number 1 is only the basis, I would say.
So I'm dying because I'm an entrepreneur and you're planning to have like a product in 2030. How can you finance a company based on that timeline?
Well, we have already had a lot of Innovation Norway funding, and we have private investors, luckily. Otherwise, it wouldn't go. Yeah.
All right. Good pitch then, huh?
Hmm?
A good pitch then.
Yeah. Yeah. Okay.
Any more questions? Okay. Thank
Okay.
you.
Thank you.
That ended the session for this time. Still some food left, and the bar is also open, so you can mingle around a little bit here and before we maybe continue. Fargegaten is close by, so you can nice places there as well. Okay, thank you for now. Ja.